Hello everyone and welcome back. I hope you are doing well and enjoying the course so far. This is our third video lesson in Mathematics for Natural Science course, which focus on open statements. And remember, mathematics is best learned through practice. So stay engaged and even challenge yourself as we work through the lesson together. Let's get started. Now, an open statement is a sentence involving a variable or variables that becomes a preposition when the variable or variables are replaced by particular values from a given domain. So when you say open statement, it means what? Sentence containing variable, one or more variable. And this sentence containing a variable will be converted to open statement when we replace the variable or the variables by the corresponding values from their domain. So such sentence, we call it open statement. Now let's take example. X is the capital city in Africa. And this statement, open statement, will be converted to a true or a false statement when we replace X by its value from the domain. So a sentence containing one variable and becomes a preposition when the value of the variable is known. We call it what? Open statement. Now, open statement may contain more than one variable. For example, if you take y is the multiple of what? X. If we replace x and y with numbers from the domain, this becomes either true or what? False. So this is the definition of open statement. By the way, it doesn't mean every sentence containing variable is an open preposition. Now the other point, to denote open statement, we use P of x or Q of x. This means x satisfies property of P. Now, if x satisfies the property of P, it will be true. If x doesn't satisfy the property of P, it will be what? False. And when we combine two or more open prepositions based on prepositional connectives, we will get a compound or a complex preposition. For example, considering P of x, open statement with variable x, and R of xy, open statement with two variables xy. When we combine these two based on logical connectives, the resulting statement, we call it compound open statement or complex open statement. This is also important. Now, once we know the definition of open statement, the next point is how we can check whether two open statements are equivalent or not. So by definition, two open statements will be equivalent if they have the same truth value for every value of the variable or variables in their domain. That means for each and every value of the variables from the domain, if the two open statements have the same truth value, we call them equivalent. Now, to understand this concept, let's take two open statements. P of x, x squared minus 1 is equals to 0, and the second, Q of x, absolute value of x greater than or equals to 1. Now, considering these two open statements and the domain, x, an element of u, the variable x, in both open statements, the variable x is taken from the universal set. So our domain contains four numbers, minus 1, minus half, 0, and 1. So consider x can be one of these four. So P of x and Q of x will have the same truth value for each number in the domain of our example. That means when you insert negative 1 inside P, minus 1 squared, 1 minus 1, 0, it is true. If you insert positive 1 squared, 1 minus 1, it is what? True. So P at plus 1 minus 1, the truth value is what? True. Q at plus 1 minus 1, absolute value of 1 as well as absolute value of negative 1 is greater than or equal to what? It is true. So both PQ have what? The same truth value for 1 as well as for minus 1. Similarly, PQ have the same truth value for minus half and 0. So for every x from the domain, the two open statements P of x and Q of x have what? The same truth value. Because of that, the two open statements are what? Equivalent. To change open statement into a statement, the first method, like we did in this example, the first method is what? By replacing the variable with the value from the domain, you can convert open statement into what? A true or a false statement. By replacing the variable with value from the domain. This is one way of changing open statement into a statement. Now the other method is by attaching quantifiers. We have two important quantifiers in mathematical logic, the existential quantifier and the universal quantifier. So without substituting individuals for the variables, by attaching existential or universal quantifier to open statement, you can convert the open statement into a true or a false statement. So the two quantifiers are the existential quantifier, which is denoted by this. This is called existential quantifier, which means there exists. The second, inverted capital A, universal quantifier, we call it universal quantifier, and the meaning is for all. Now let us see the two quantifiers one by one. For the existential quantifier, let P of x be an open preposition. So when you attach existential quantifier, you write in this form, there exists x, P of x. There exists x, P of x. And the meaning is there exists an x that satisfies the open statement P of x. So if you can get at least one x that satisfies the property of P, it will be what? A true statement. If there is no a single x from the domain that satisfies the property of P, this becomes what? False. So in both cases, we convert open statement into what? A true or a false statement by attaching the existential quantifier. There exists. So let's take example. For x, an element of real number, our domain, the set of real number, let's consider open statement P of x, x squared plus 1 is equals to x. So x squared plus 1 is equals to x. This is a sentence containing variable x, so it is an open statement. Now without inserting value for the variable, we are going to attach what? The existential quantifier here. There exists x, P of x. This will convert the open statement P of x into what? A statement. This is a statement because there exists x, P of x is a false preposition. It is a false preposition because it means what? There exists at least one real number x that satisfies the property of P. We don't have a real number that satisfies this equation. So there exists x, P of x is what? A false preposition. That means we convert open statement into what? A false statement by attaching existential quantifier to the given open statement. As a reason, you can take always x squared is greater than or equals to x for all real numbers. So when you add 1, x squared plus 1, for sure it will be greater than what? X. It cannot be equal to x. Because of that, the statement there exists x, P of x, is what? A false statement. Because the meaning is what? It says there is at least one real number where the square plus 1 is equals to x, which is false. We don't have such a real number. So this is a false preposition. Let's take another example so that you understand the concept behind. Let's take open statement Q of x, which is x plus 2 times x minus 3 is equals to 0. This is a sentence containing variable x. So it is what? Open statement. Now when we attach existential quantifier to the given open statement, there exists Q of x. Now this becomes what? A preposition. Because there exists Q of x is a true statement. We can get at least one real number that satisfies the property of Q. Not only one, we have two. If you insert negative 2 or 3, this property of Q will be what? Satisfied. So there exists at least one x, or there exists at least one real number that satisfies the property of Q is what? A true preposition. So we convert open statement into what? A statement by attaching existential quantifier to the given open preposition Q. Now the third, less r of x, open statement r of x be, absolute value of x is equal to negative 2. So there exists r of x is what? False preposition. Because absolute value is always what? Greater than or equal to 0, because absolute value of x means distance from origin up to x. Always distance is positive or 0. Because of that, we cannot get any real number that satisfies the property of R. Because of that, this statement is what? False preposition. False preposition means we convert open statement into what? A statement by attaching existential quantifier to R of x. Now let's proceed to the second quantifier, the universal quantifier for an open preposition P of x. For all x P of x, just when you attach universal quantifier to open preposition, this is the way you write. For all x P of x. It means what? All x satisfy the open statement P of x. So if all from the domain satisfy the open statement, it will be true. If not, it will be what? False. Let's take example. Again, our domain x is taken from real number. So P of x, x squared minus 5 is equals to x. The open statement containing variable x, x squared minus 5 is equals to x. So for all x, P of x is false preposition. Because all real number will not satisfy the property of P. So the open statement is converted to what? A statement by attaching the universal quantifier. Q of x, x squared greater than or equals to minus 1. Now for all x, Q of x is what? A true preposition. Because for all real numbers, the square is what? Greater than or equals to negative 1. Because of that, this statement is what? A true statement or a true preposition. So by attaching the universal quantifier into the open statement Q of x, we convert a statement containing variable open statement into what? A true statement. Now the third, let R of x represent x less than x squared. So for all x, R of x is a false preposition. For all x, R of x, all real number satisfy the property of R is what? False preposition. Why? Because of 0, for all real number, R is satisfied is what? A false statement. So to say for all x, R of x false, one real number is enough. Meaning, if you get one value from the domain which dissatisfies the property of the open statement, for all x, R of x becomes what? False preposition. In order this to be true, all must satisfy the property of R. I hope you have the idea. Now let's proceed to the second point. We are going to relate existential with what? Universal. Now for any open preposition P of X, that's the way we read. The negation of there exists X P of X is equivalent to for all X, the negation of P of X. Now the meaning is what? No X satisfies the property of P. So if no X from the domain satisfies the property of P, this means all X do not satisfy the property of P. So these two are equivalent. Again, the negation of for all X P of X is equivalent to there exists X negation of P of X. Meaning, it is not true that all X satisfy the property of P means there exists at least one X from the domain which dissatisfies the property of P. So we can relate existential and universal based on these two important remarks. Now let's see it based on example. Considering P of X, X is equals to X squared, then there exists P of X means there is what? An X from real number such that X is equals to what? X squared. This is true. There exists P of X is true because we can get a real number where the real number equals to it square. If you take 1, 1 is equals to 1 square. If you take 0, 0 is equals to 0 square. So there exists P of X means there is an X from real number such that X is equals to X square. Now if you take the negation of there exists P of X, the negation means what? There is no X from real number such that X is equals to X square. No X satisfies the property of P. So if no X satisfies the property of P, that is the same as all X dissatisfies the property of P. So if this is false, this is also what? False. Because there exists X P of X is true. We have at least one real number that satisfies the property X is equals to X squared. So there exists X P of X is a true statement. So when you take negation of true, it will be what? False. So this is false. So if this is false, for all X, the negation of P of X is also what? False. Because it says what? All real number do not satisfy the property of P, which is false. And for the second, for all X, P of X means all real number, for all real number, the real number equals to its square. X is equals to X square, which is false. So for all X, P of X is false because all real number cannot satisfy the property X is equals to X square. So this is false. So when you take the negation, it will be what? True. It is not true that all X satisfy the property of P, which is true. In other words, it is not true that all X satisfy the property of P means there is some X where X is different from X squared. So there is some X which dissatisfy the property of P. So all X satisfy the property of P is false. The negation of all X P of X is what? True. This is true, so this is also true because there exists at least one real number where that real number is different from its square. True. So in this way, you can relate existential with what? The universal quantifier. Now, so far we were considering open statement containing only what? One variable. Now to convert open statement containing one variable into a statement, we use existential or what? Universal quantifier at the time. In case the open statement contains two variables, to convert open statement containing two variables into a statement, we are going to use both at the same time. Now the way we attach is based on this one. Now consider open statement containing two variables x and y. P of xy means open statement containing two variables x and y. So when we attach, the first option is what? For all x, for all y, P of xy. What is the meaning? For every x and every y, x comma y satisfy the property of P. For every x and every y from the domain, the order pair x comma y satisfy the property of P. So if for every x and every y from the domain, if x comma y, the combination x comma y satisfy the property of P, it will be true. But if there exists at least one possible pair which dissatisfy the property of P, it will be what? False. So P of xy, open statement containing two variables, is converted to what? A true or what? A false statement. Now the other option, we can use existential quantifier twice for the two variables to convert open statement into a statement. So there exists x, there exists y, P of xy. So if you can get at least one x and one y, where x comma y satisfy the property of P, it will be true. Otherwise, it will be what? False. So we convert the open statement containing two variables into what? A true or a false statement by using existential quantifiers twice for the two variables. Now when we combine existential with universal, the first form is what? For all x, there exists y, P of x. For all x, there exists what? Some y. So if you can get for all x some y, where x comma y satisfy the property of P, it will be true. Otherwise, it is what? False. Now the last one, there exists x for all y, P of xy. Now the way we understand this one is important, because according to the prepositional logic, this means there exists some x, a fixed x, for every y. A unique x for every y. If you get a unique x for every y where x comma y satisfy the property of P, it is true. Otherwise, it is what? False. So for an open statement containing two variables, to convert open statement into a statement, you can attach existential quantifier twice or universal quantifiers twice, or you can combine existential with universal or universal with existential. So based on one of these four, you can convert the open statement into what? A statement. Now let's take example so that you can understand the way we apply quantifiers to convert open statement into a statement. Now let's consider open statement containing two variables where P of xy is x is less than y and xy taken from what? A real number. Our domain is the set of real number. So for all x, for all y, P of xy. What is the meaning? For every x and every y taken from real number, x is less than y, which is false. Because it will not work for every x and for every y. If I take, for example, 0 for x and minus 1 for y, 0 less than minus 1, it is what? False. So this inequality doesn't work for every x, y you choose from the set of real number. So for all x, for all y, P of xy is what? False. That means we convert this open statement into what? A false statement by attaching the universal quantifiers twice. Again, there exists x, there exists y, P of xy, it is true. Because the meaning is what? There exists at least 1x and 1y, we satisfy the property x less than y. True. Let alone one pair, we can find what? Infinitely many pairs. We satisfy the property of p of xy. If I take 1, 3, 1 is less than 3, true. If you get one pair, x, y, we satisfy the property of the open statement containing the two variables. The statement becomes what? A true statement. Now the third, for all x, there exists what? Y, p of xy. It is true. Because it means what? For all real number, we can find another real number where x is less than what? Y. Or in other words, for nx from real number, we can get what? X plus 1, which is greater than x. So y will be what? X plus 1. Y will be x plus 1. So in this case, y is greater than from what? X. So for all x, there exists y, p of xy is a true statement. Now the fourth, there exists for all y, p of xy. Remember, logically this means what? There is some x, fixed x, which works for every y, where x is less than y, it is false. Because we don't have a number which is less than from all real numbers. Since a number has no unend, from minus infinity up to positive infinity, whatever real number you take, you can get a real number less than the chosen number. So because of that, this is what? False. Now based on the concept we have seen, try to solve the following exercise. Yes, we try to see the definition of what? Open statement with one variable and with what? Two variables. And we try to see how we can convert open statement into a statement by replacing the variable or the variables with the corresponding values from the domain, or by attaching the existential or universal quantifiers to an open statement. We can convert an open statement into what? A statement. So try to solve the following four exercises. Just determine the truth values of each of the following prepositions, 1 up to 4, plus just 5 up to 8, considering p of xy, which is x less than or equals to y squared. Try to determine the truth value 5 up to what? 8. I hope you understand the concept of open preposition and how we can apply quantifiers to convert open preposition into what? A preposition. So next time we are going to start the validity or invalidity of an argument. Goodbye and take care.